This is Blackthornprod. I'm Noah and welcome to another AI tutorial using Unity and the C# programming language. Today we're going to dive into the realm of 2D platformers by making a simple yet classic patrolling behavior. As you can see, I have this simple sprite that acts as my placeholder NPC. He behaves in a very straightforward manner, moving forward in a straight line until the edge of the platform is reached, at which point he turns in the other direction. Where things get interesting is if we begin scaling the platform in the X direction. As you'll notice, the character will still detect the edges of the platform and act correspondingly. To achieve this, we will be using rays, a fundamental programming tool which consists in creating an invisible line that can grab information and modify objects it happens to collide with. With all of that said, let's begin. Like with many of my game dev C# videos, I'm using simple placeholder graphics as to keep things nice and clear. In this case, I have this bland black square and a circle with two white eyes. Grabbing my platform, I'll add a 2D box collider and leave all of its settings at default. With that done, I'll create a new C# script, call it Patrol, and open it up inside of my scripting editor, MonoDevelop. I'll begin by creating a public float speed variable, which obviously will dictate how fast our character will move across the platform. I'll then make a private bool variable named movingRight and set it equal to true. We will be using this to tell our character, once he has reached the edge of the platform, where he must now move to. Coming up next, I'll make a public transform variable called ground detection, and once that's done, I'll head back to Unity, create an empty game object called ground detection, add a little gizmo to it so we can easily detect it in the scene view, and make it a child of our patrolling character. I'll now place it in front of the character and just a tad above ground level. We will be shooting out our invisible ray from this empty game object. So when our character moves across the platform and the ray shooting out from the empty game object no longer detects any collisions, then we know it's time for our NPC to turn the other way. All of that sounds awesome, let's now code it. So in my update function, I'll begin by getting my character to move forward. Now for this video, I won't be using any rigid body to get my patrolling sprite moving. I'll simply use transform.translate and inside the parentheses, state in which direction I want to move to, so vector2.right, and I'll multiply this by speed and time.deltaTime. Now my character will elegantly move right. But of course, we would like him to also move left when he reaches the edge of the platform. So let's create a ray. To do so, type raycast2d and give it a name. I'll call mine groundInfo and set it equal to physics2d.raycast. Now that tricky bit of syntax is out of the way, we will fill in the parentheses with an origin for our ray, a direction, and a length. So I would like the ray to start at the position of the ground detection variable we created a few moments ago, and I would like my ray to shoot downwards. This way it will be able to tell me whether or not it's collided with ground. Lastly, I'll put in a small value of 2 for the ray's length. Of course, you can create a variable for this value instead of hard coding it. Note that you do not need to state the ray's length. If you don't, the ray will simply shoot off into infinity. With the ray created, I will now make an if statement and check whether the ray has actually hit anything. So just type in groundinfo.collider == false. If the ray has not collided with anything, then we now know that it is time to turn our character in the opposite direction. And this is where our moving right bool variable comes into play. So we will check with another if statement whether we were moving right, and if we were, well then it's time to move left. I'll simply rotate my character of 180 degrees along the y-axis for him to move in the opposite direction. To do so, type in transform.eulerangles equals new vector 3, and in the parentheses state the rotation values you would now like your character to have. And of course, I'll now set the moving right bool variable to false, since we are no longer moving right, but we are moving left. However, if when we reach the edge of the platform we were moving left, then we will simply set the character's rotation values back to 0, and also set the moving right variable back to true. Alright, awesome. Let's head back into Unity, drag and drop our ground detection transform variable inside of this empty slot, type in some value for speed, and press play. And if you've done like me, then you should now have a lively character moving back and forth across a platform. And like I showed you at the start of the video, you can scale the platform and the character will still, with its sophisticated AI, stop at the edge of the platform and turn in the opposite direction. With that said, I genuinely hope you enjoyed the video and learned something new. Of course, thanks so much for watching. Don't forget to support Blackthornprod by generously hitting the like and subscribe buttons. Okay, see you very soon for more game creation content. Cheers, guys!